I want you to go back in time and think about the days when you were in high school. Most likely, you were assigned a roll number that could identify you uniquely amongst a group of students. As you moved ahead in life, probably you gave some entrance examinations. And now this roll number, it became even longer. Moving ahead in life, maybe you have joined some company and now you are being assigned a employee ID. So what is actually happening at all of these steps? You are assigned a unique number that identifies you and only you. That is because it is very much possible that there can be multiple people with the same name and even with the same birth date. So you need a system such that someone can pinpoint to you. And if you notice, as you move ahead in life, this ID becomes even larger because the pool of people amongst which you need to be uniquely selected, that also grows in size. So this was the scenario when it was just people. Think about a distributed system where you have so many different resources. You have images, videos, songs, comments, so many things. So certainly you need a way to uniquely identify each of these resources. And that is why generating unique IDs in a distributed system is very, very essential. Hello friends, welcome back to my channel. In this particular video, we are going to discuss what is the importance of a unique ID generator and some of the different methods by which you can achieve this. We are also going to discuss some of the pros and cons of each of the methods. Note that there is not a single method that can say that yes, this is the absolute and this is the best. You always need to keep in your mind, okay, what are my requirements and which method will be best for me. So before moving into all of that, let us do a quick recap about what all have we already discussed. So when it comes to system design, we have learned why is it essential and what do you mean by scaling a system. After that, we started discussing all of the fundamental concepts like a client server model, a load balancer, caching, databases, and all of those stuff. Using all of them, we compiled them and then started creating diagrams. Once you have now created all of this system, it is time that you start to optimize them. And we use things like indexing, proxies, message queues, CDNs, and all of these stuff. We were also able to relate everything with the example of a real life bookstore because that is something you see every day. And then it becomes easier to relate and it sticks in your mind. So if any of these concepts is very new to you, I would highly recommend you to pause the video right over here and watch my previous videos first. Because now we are getting into the territory of designing some of the essential components. We discussed about the gap theorem and we also designed a rate limiter. So now we are gonna make up all of these building blocks, which will then eventually help us to create even larger systems. Coming back to unique IDs now, where do you think you might need them in a distributed system? Well, you might be surprised that they are used almost everywhere. For example, when you are browsing posts on a social network website like Instagram, each of the posts that will have a unique ID. Similarly, when you're looking for videos on YouTube, each video has a distinct ID. Even this video, if you look in your browser URL, it has a particular ID that is unique to all of the videos in YouTube. Similarly, you can have a unique ID for each song on Spotify. You can have a unique ID for every order that is placed on an e-commerce website. Similarly, you have unique IDs for comments on social network. You have unique IDs for all cash transactions, for all IoT devices, and even unique IDs for all messages in an event-driven architecture. So you can see that a unique ID has a huge application. And you want that whatever system you are implementing, it generates these user IDs in a very fast manner. Because you might have seen that for any post, you have 10,000 comments. So you need a system that is generating these 10,000 unique IDs at a very fast pace. So that is the requirement over here. When you start designing such a system, at first it may seem very, very simple. For example, let us say you want to generate user IDs for all of the new users that are signing up on your website. So what you can possibly do is you can maintain a database and it has a simple table. you have user ID and all of the names. So for this user ID column, you can just auto increment all of the values. So it will have values like 1, 2, 3, 4, 5, and so on. And then you can have a name associated with each of the ID. So each name is getting a unique ID associated. So you were able to solve this problem, right? But there is a problem. This scenario is only valid when your application is running on a single server. Think about a case when your application is distributed. Distributed simply means that you have your servers lying all over the world. So, in such a scenario, you have all of these different servers and they are connected. Think about a case if you employ the same algorithm now. So, this server is generating 1, 2, 3, 4 IDs of its own. This is again generating 1, 2, 3, 4 IDs of its own. And this is again generating 1, 2, 3, 4 IDs of its own. And it can be very much possible that a name that exists in this particular server also signed up in this particular server. So what just happened? This ID is no longer unique. A single ID can map to two different users. So this method will not work for you. And that is why this problem starts to get more and more complex. And rather, when it comes to distributed systems, there can be a lot of different requirements when it comes to unique IDs. So, if you find this problem in an interview, always ask your interviewer what all requirements that they have. Definitely, they want to be unique. Your interviewer can also say that, hey, I want all of these IDs to be sortable as well. It could be their own use case that they want to implement. And there can be additional cases that how fast do you want these IDs to be? What should be the length of these IDs? It can be a 32-bit long ID, it can be a 64-bit long ID, it can be a 128-bit long ID. So all of these are different requirements and you must clarify what is the end result. What do they actually want? And based upon that, you should come up with a solution. I'm going to discuss some of the methods by which you can implement a system that is generating unique IDs for you. The first method that I'm going to discuss is the multi-master replication method. So over here, I have all of these different servers that are in different regions and they are connected with each other. You still want to generate unique IDs for each of the resource. So what you can do? You know that you have, let us say, k equals to 3 data centers. So instead of incrementing values by 1, 2, 3, and 4, what you can do is you can put the starting value as 1, 2, 3. Now you have 3 values assigned. The value of k equals to 3 and that is the offset. So instead of incrementing by 1, what you can do is you can increment each value by 3. So what will happen now? This center will generate 1, 4, 7 and then a 10. This center will generate 2, 5, 8 and 11. The third center will generate 3, 6, 9 and a 12. All of these servers are in different region and all of them are generating IDs that are still unique. So once again, you were able to solve this problem. You have unique IDs for each resource. So although this system is easy to implement, it has a major drawback. It is not easy to add and remove new data centers because as soon as you do that, you have to now synchronize all of your data centers once again. And also, you must have information about how many servers do I have. For example, if you have 4 servers, you need to have this information with you. The servers just cannot independently generate IDs and they are guaranteed to be unique. So let us try to solve this problem now. The next method we are going to discuss is by using UUIDs or universally unique identifiers. You might have seen values like this, correct? These are 128-bit long identifier IDs and they can be generated by any server. Also, they do not need to have any information about all of the servers that are available in the network. Since this ID is 128 bits, you have a lot of different combinations possible. In fact, it is said that if you generate billions of these GUIDs per second, then it will take almost 100 years to have the first duplicate ID. So it is kind of very safe to say that you can use these IDs as a unique ID when it comes to your resources, because you can have a distributed network. So you have all of these servers available, and each of the server will have a ID generator. Now they are generating a unique GUID, and there is a very high chance that all of them will be unique. So you are able to solve your problem. You are able to assign a unique ID to each of your resource, and there will not be any duplicates as well. So is this method perfect? Well, you can say that it is simple in the terms that you do not need any kind of coordination between the servers. Also, it is easy to scale. You can keep on adding more servers to your network, and you are guaranteed that there will be no collisions among all of the IDs that are generated. But there are some drawbacks about this method. The first drawback being this ID is 128 bits. This is substantial and it requires some storage space. Sometimes that may be a constraint and you might not be allowed. Second, these IDs are alphanumeric. You might have a use case that you want IDs to be only numbers. So in such a scenario, this method won't be feasible. You might also have a condition that you want all of your IDs to be sortable. So since these IDs are random, these are not sortable also. So while this method has some of its advantages, it comes with own set of disadvantages as well. We need to consider both of them before we pick this method as our favorite method to generate UIDs. The next method we are going to talk about is the ticket server method. And this method was developed by Flickr. You might be knowing about Flickr. A lot of photos get uploaded onto the website and they quickly want new unique IDs for each of the photo uploaded. So what did they do? For example, you have all of these different servers in different regions around the world. Photos are uploaded to any of these servers. You need unique IDs. So what do these servers do? These servers will contact a central system, and this central system acts as the ticket server. For any resource that is uploaded, a server queries this ticket server and it gets back a ticket. This ticket is the unique ID. So you can be sure that all of these servers, whatever ID they are using, it is unique because it is being generated from a single point. And then this ticket server is responsible for generating these IDs at any speed that we want. If we want alphanumeric, this will give me alphanumeric IDs. If we want numeric, it will give me numeric IDs. It just depends on what do we need. It is also possible that it gives me different IDs for images, it gives me different IDs for users, it gives me different IDs for videos. It all depends upon the use case. If you expand upon this ticket server, your internals might look something like this. You have this entire component and inside you are maintaining two databases. So one of the databases can be generating IDs like 1, 3, 5, 7, and the other one might be generating IDs like 2, 4, 6 and 8. So now both of these databases are giving you unique IDs. So whenever these servers contact the ticket server, you might have a load balancer in between, and this load balancer helps you to distribute the load amongst all of the servers that I have in the ticket server. And having multiple servers over here also gives me high availability. If one of the servers goes down, then this server can continue giving tickets. And in the meantime, you can recover this server back up. So this is how the internals of a ticket server design look like. If you think about it, this kind of a system solves a lot of problems for you. It is easy to implement and it gives you unique IDs in any format that you want. However, it is not good for a very huge system. For example, if you have a system or an app that is spread all throughout the world, then getting tickets from a single server, that is not feasible. You will waste a lot of time just making all of these connections. And the biggest disadvantage of such a system is single point of failure. If your ticket server goes down, or if the network connections from this server goes out, then your entire system might be compromised. You are not able to get unique IDs for any of the images that are uploaded. So that is where this system is not feasible. If you think about it, we are now streamlining our approach. We are able to design an efficient system. But in this system also, there is a very big drawback. You are dependent upon a certain server to give you unique IDs. So if we can get around that part, then we are able to reduce the dependency on all of the other servers that are in my network. And that can give you a very good approach. And that is where the Twitter Snowflake approach comes in very, very handy. It is now called as X. But with this system, Twitter was able to handle unique IDs at a very, very fast rate. They had a lot of tweets coming in, and this system gave you multiple unique IDs in just a matter of seconds. I'm going to give a link of all the different articles for all the methods that I have discussed. But if we want to see how the Twitter Snowflake approach actually worked, it worked on the divide and conquer approach. And that is very, very helpful. They started to use 64 bits in total to represent a unique ID. And several parts of these 64 bits were used in different ways. For example, the last 12 bits, they were a sequence number. So they can start as 0, 1, 2, 3 and all the way up to 1, 1, 1, 1, 1. That means you have 2 to the power of 12 combinations available over here. The next 5 bits were used for the machine ID. For example, in a data center, you can have different machines. So this is again giving you 2 to the power of 5, that is equal to 32 different machines. Next, you have 5 bits for a data center ID. So this is giving you a maximum of 32 data centers possible. And that is a pretty big number because 2 to the power 5 is again 32. So you are seeing that how these bits are being used to get unique IDs. The next 41 bits, they represent a timestamp. For every passing second, you can have all these different combinations possible. So you can see that even though I have 100 different servers possible, I use this particular combination to generate a unique ID for any resource that I might have. And we use the last bit as a reserve. This is representing a positive or a negative number. It is used in very special scenarios where a system is interpreting negative numbers differently. So do not be concerned a lot about it. The interesting part about this is all of these different bits. So in such a system, you are not dependent on any of the other servers that are connected. And just by being on a single machine, I can generate IDs. And they are guaranteed to be unique. As you can see, this system has a lot of good things about it. First of all, it can give you unique IDs without any collisions. It doesn't even need to know what other servers are connected. It can give you unique IDs independently. Second, it is fast. Third, it can give you sortable IDs. And if you notice, this ID has a timestamp built in. So this gives you an extra piece of information. And whenever you're looking at these IDs, you have this information available, which can come in very, very handy. Given all of this information, this method is probably the most robust implementation when you want to have a unique ID generator. But at the same time, you must keep in mind some of the caveats as well. For example, time synchronization is very, very essential. Let us say you have 10 different servers available. Even if the time is off by 1 second between two servers, there is a chance that you can generate duplicate IDs. So time synchronization is very, very essential. And this can make the implementation of this method a little bit complex. Also, this method might be a little limited. For example, you have these 41 bits that represent the timestamp. This is good for 69 years. But after that, you might need something different. So naturally, you can see that every method will come with all of its disadvantages as well. Whenever you see these kind of questions in an interview, I always say, discuss everything. Ask them what do they want, how would they like their system to be, and only then come up with a solution. Do not just keep a straight mind and implement something that you already know. talk about it, and maybe take hints from the interviewer. Ask them their specific needs and then create a system. So, while going throughout the video, did you face any other problems? Or what other interesting methods have you found that gives you unique IDs without depending on all of the different servers that I have attached? That is the most important part because it gives you the scope that you can generate IDs independently. So just tell me everything in the comment section below and I would love to discuss all of it with you. As a reminder, if you found this video helpful, please do consider subscribing to my channel and share this video with your friends. This keeps me motivated and I can make more such videos. Also, a huge shout out to all of the members who support my channel. You guys really keep me going. And as a member, you do get priority reply to your comments and early access to new videos as well. Stay tuned for my next video. Until then, see ya.